Now in today's video, we will start with the question 3. The question 3 says that in a toy factory, quality checks were performed on 65 batches of toys of check for defects. The frequency distribution is given in the table below. So here we have a 65 batches of toys to check for defects. Now this particular data is group data because it is divided into small class intervals or small groups, and every group having a class size of 4. How we came to know that the class size is 4? So we will subtract the upper limit, that is 4, of the first group. We will subtract 0 from 4, so it will gives us 4, and it is the class size, and it will be fixed along each group. So there is a difference of 4 for the class intervals 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20, 20 to 24, and 24 to 28 respectively. And now we have the corresponding frequency for each class interval or group. Now we can see the first entry of the regular frequency table. It's from 0 to 4, number of defective toys with a frequency of 21. So we can just copy it as it is into the cumulative frequency table as well. From 0 to 4, we will take only upper class boundary of the first class interval, and that is x less than equals to 4. So we can just copy it as it is into the cumulative frequency table as well. From 0 to 4, number of defective toys with frequency of 21. But here there are changes. So now we are going to look at the next entry from 4 to 8 with a frequency of 18. But because this frequency is cumulative, we are going to include all of the previous frequencies as well. This means we want to include all of the defective toys from first class interval and all of the defective toys from the second class interval. If we are going to get all of those defective toys, then we need the number of defective toys that are from 0 to 8. Now for our next entry, the number of defective toys goes from 0 to 8, and we could just add on 18. So for our next entry, for our second entry, we have to go from 0 to 8 with a frequency of 18. So we have to just add on 18 to the last one, which was 21. So 21 plus 18 gives us the cumulative frequency of 39. Now if we move on to the third entry, we want to include this class interval from 8 to 12 with a frequency of 14. But also both of the previous two class intervals, we have to consider both of the previous two class intervals as well. So if we are going to get all of those number of defective toys, so the number of defective toys must goes from 0 to 12. So we are taking x less than equals to 12 for third entry, and then we could just add the new frequency 14 onto the previous total. So 39 plus 14 gives us the cumulative frequency of 53. We then just Repeat this process all the way to the end of the table. So for the next class interval from 12 to 16, with a frequency of 6, number of defective toys now need to be goes from 0 to 16. So we are taking x less than equals to 16. We can just add on this new frequency of 16 to the previous total, and that was 53. So 53 plus 16 gives us the cumulative frequency of our new frequency is not 16, it's 6. I have a mistake. So 53 plus 6 gives us 59. The new cumulative frequency for the fourth entry will be 59. Similarly, for the fifth entry, the class interval goes from 16 to 20 with a frequency of 3. So the number of defectives need to go from 0 to 20. So now we are going to get all of the number of defectives. We can add on this new frequency of 3. We are considering x less than equals to 20, and we will add new frequency of 3 to the previous total of frequencies, that was 59. So 59 plus 3 gives us the cumulative frequency 62. Now for the sixth entry, the class interval from 20 to 24 with a frequency of 2. The number of defectives needs to go from 0 to 24. So here we have x less than equals to 24. And now we will add this new frequency of 2 into the previous total. So 62 plus 2 is equals to 64. So it will give the new cumulative frequency for the sixth entry of 24. Now for the last entry, the class interval of 24 to 28 with the frequency of 1. The number of defectives must need to go from 0 to 28. Now we are going to add on this new frequency of the previous frequency 1 to the previous total, and there was 64. So for the last entry we are taking x less than equals to 28, and now we will add this new frequency of 1 into the previous frequency's total, and that is 64. So 64 plus 1 is 65. So the final cumulative frequency is 65. So this is the completed cumulative frequency table. Since we have constructed the cumulative frequency table in the part 1, now in the part 2, the batches were graded as follows. For the grade 1, more than 20 defects. Grade 2, more than 12 and less than or equal to 20 defects. For grade 3, more than 4 and less than or equal to 12 defects. Using the cumulative frequency table, we have constructed find the number of the batches graded as in the part 2a grade 1. Now to find out the number of batches graded as grade 1 in the part 2a of the question 3. Since it is given in the question that for grade 1 was graded as more than 20 defects, so since we have a cumulative frequency table of less than equal to type, so the number of defects more than 20 does not given in the cumulative frequency table. So for this we have to subtract the number of defects less than equals to 20 from the total number of batches. take away number of defects less than or equal to 20. Why we have to subtract the number of defects less than equal to 20 from total number of batches? It's simple. To find out any quantity that is greater than some number, so we will subtract the reverse of that quantity. In other words, if we want to find out the number of defects more than 20, we have to subtract the number of defects less than or equal to 20. So we have to pick the cumulative frequency from cumulative frequency table corresponding to the number of defects less than or equal to 20 is 62. So 65 minus 62 is equals to 3. So the number of batches graded as grade 1 is equals to 3. That our answer is correct or not, we just simply add this 3 into 62. So 62 add 3 is 65, which is equals to total. So it means we are going in the right direction. Now in the part 2b, we have to find out the number of batches graded as grade 2. So in the question, what is the description for the grade 2? The grade 2 is graded as more than 12 and less than or equals to 20 defects. So here to find out the number of batches graded as grade 2 will be equals to the more than 12 and less than or equals to 20 defects. Since for less than or equals to, we have two limits. The upper limit is less than or equal to 20 defects and more than 12 is our lower limit. So for upper limit we have x number of defects is less than or equals to 20. So the cumulative frequency in the case of x less than equals to 20 is 62 minus. Now for more than 12. So for more than 12, the value of the cumulative frequency is 53. So here we have 53. So 62 take away 53 is equals to 9. So the number of batches graded as grade 2 is equals to 9. Now for part 2c, we have to find out the number of batches graded as grade 3. So grade 3 has a description more than 4 and less than or equals to 12 defects. So the number of batches graded as grade 3 is equals to our upper limit in the case of grade 3 is less than or equals to 12. So for less than or equal to 12 we have the cumulative frequency of 53. So here we will write down 53 minus, and our lower limit is more than 4. So for x less than equals to 4 we have a cumulative frequency of 21. So here we have the 21. 53 minus 21 is equals to 32. So the number of batches graded as grade 3 is equals to 32. In the part 3, explain why it is not possible to state the number of batches which have at least 16 defects. The cumulative frequency table is based on less than or equal to frequency. Since it is not possible to find out the number of batches which have exactly 16 defects. It is not possible to find out the number of batches, to state the number of batches which have at least 16 defects. Now in the part 4, if a batch is chosen at random from the batches, find the relative frequency that the more and that was 39. So the total number of batches is equals to 65 and the cumulative frequency for the number of defects less than or equal to 8 is 39. So here we have 26. Now we have to find out the relative frequency. So the number of occurrences we have find out here is 26 and the total number of trial or the total number of batches is 65. So here we have 26 over 65. Now with the table of 13, we have 13 to the 26 and 13 5s 65, so 2 over 5. So the relative frequency that the batch has more than 8 defects is equals to 2 over 5. Question 4. The masses in kg of 100 people were measured. The cumulative frequency curve shows the mass x kg and the number of people with mass less than or equal to x kg. So in the part 1, use the curve to estimate the number of people whose masses are less than or equal to 65 kg. Now to solve the now to find out the number of people whose masses are less than or equal to 65 kg. First we have to understand the scale of x-axis and the y-axis. So for the x-axis we have scale 62 minus 60 divided by the number of jumps or number of square between these two values. So the scale for x-axis will be equals to 2 over 5 and that will be equals to 0.4. So each square having the value of 0.4. So now scale for y-axis. We will subtract 0 from 10 and divided it on the number of squares between 0 and 10, that is 5. So 10 over 5 will be equals to 2. So each square on the y-axis is equals to 2 units, and each square on the x-axis is equals to the 0.4 units. Now we can easily solve the part 1a. So we will use the curve to estimate the number of people whose masses are less than or equal to 65 kg. So for this, if we have the scale along x-axis is equals to 0.4 units for each square unit. So if we have 64, then the next point will be 64.4, and after that we add 0.4, so we have 64.8. Now after that, if we add 0.4, so we have the next point is 65.2, and after that the next point will be 65.6, and if we add further 0.4 into 65.6, then we will get 66. So the 65.2 will be approximately equals to 65. So on the graph, after 64 we have 64.4, then 64.8, and then here we have 65 on the third square. So then we will draw a vertical line from x is equals to 65 kg on the horizontal axis until it intersects the curve. So where is the 65? Here is the 64, 64.4, 64.8. Now 65.2, which is approximately equal to 65. So now we will draw a vertical line from the horizontal axis until it intersects the curve. So this is the point. Here it intersects the curve, and then from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. Since we know that each unit along the y-axis is equals to 2, so here we have 20, 22, 24, and it is equals to 26. So the reading of 26 indicates that 26 people whose mass is less than or equal to 65 kgs. So now in the part 1a, the number of people whose masses are less than equals to 65 kg is equals to 26. Now for the part 1b, we start from 68. Then since we know that each unit square is equals to 0.4 units, so here we have 68.4. Now we have 68.8 and so on. So since we have to find out the number of masses who are more than 68.6, for 68.4 here on the second, 68.8. So we're 68.8. We have 68, 68.4, 68.8. From here we will draw a vertical line until it cuts the curve, and from the point of intersection on the curve we will draw a horizontal line until it touches the vertical axis or y-axis. So here we have 70. Since we know that each unit square is equals to 2 along the y-axis, so here we have 70, 72, 74, 76. So the reading is 76. So since the reading is 76, so the number of people whose masses are less than or equals to 78.6 kg. So the number of people whose masses are less than equals to 68.6 kg is equals to 76 according to the curve. We want to find out the number of people whose masses are more than 68.6 kg. So for this, we will subtract the number of people whose mass is less than or equals to 68.6 kg that we have estimated, and that was 76, from the total number of people, and that is 100. So 100 minus 76 is equals to 24. So the number of people whose masses are more than 68.6 kg is equals to 24. Now for part 1c, we have to estimate the percentage of the total number of people whose masses are more than 64.4 kgs. So first we have to find out the number of people whose masses are less than or equals to 64.4 kg. So first we have to identify the point 64.4 or along the x-axis, and that is, here we have 6.4 and here we have 64.4. So we will draw a vertical line from the horizontal axis until it cuts the curve. Now from the point of intersection on the curve, we will draw a horizontal line until it cuts the vertical axis. So now here we have the reading approximately 19. The number of people whose masses are less than equals to 64.4 kg is 19 according to the curve. First, we want to find out the number of people whose masses are more than 64.4 kg. We will just take away the number of people whose masses are less than equals to 64.4 kg from the total number of people, that is 100. So 100 minus 19 is equals to 81. So the number of people whose masses are more than 64.4 kg is equals to 81. Now we want to find out the percentage of total number of people whose masses are more than 64.4 kg. And for this, we will use the formula of the percentage. The number of people whose masses are more than 64.4 kg was 81 divided by the total number of people, and that is 100 divided by multiplied by 100. So this 100 cancels out with 100, and here we are left with 81%. So the percentage of total number of people whose masses are more than 64.4 kg is equals to 81%. Now in the part 2, since we have already find out the number of people whose masses are more than 68.6 kg. And that is equals to 76. And we have to find out the relative frequency. So the formula for the relative frequency is equals to number of occurrences divided by total number of trials. Number of people whose masses are more than 68.6 kg we have estimated from the curve was 24. So here we will write down 24 over 100. Now with the help of page table 2, we have 2 ones are 2 and 2 twos are 4, and here we have 2 fives are 10 and 0, and here we have 2 6 are 12 and 2 25s are 50. So here we have 6. So here we have the 6 over 25. So the relative frequency is equals to 6 over 25. So the relative frequency after simplification is equals to 6 over 25.